This morning we are gathered together in the lab of Board of Trustees, Distinguished Professor of Pharmaceutical Sciences, Diane Burgess, and we are here in the pharmacy building to talk about a new initiative launched earlier this semester called Biosensor Center for Health Intervention and Prevention, or BioCHIP, as is known for short. And BioCHIP is the first academic center of its kind in the world, which will be housing the development and application of sensor-based e-health technologies. Diane is the principal investigator for the BioCHIP initiative. Could you tell us a little bit about its purpose, why it was important to form it?
Sure. So we myself, Professor Jane and Professor Papadimitriakopoulos have been working for about 18 years developing biosensor primarily for glucose sensing for diabetics. And more recently, we have further incorporated other metabolic analytes to understand a more holistic picture of a patient's metabolism. But having done that and understanding the metabolism, the next step is how do we use that information and how do we really put together an e-health package from that can help patients. So that's why we decided to team together with investigators from CHIP, the Center for Health Intervention and Prevention, such as Dr. Amy Gorin, so that she can help us to able to develop health intervention protocols using our biosensor.
And could you show us the sensor and tell us a little bit about how it compares to other sensors on the market? I know there's nothing quite like it, or nothing like it, but
right.
Maybe talk about that piece.
Actually, we have developed here at UConn a startup company called BioRaces, and Mike Kessler-Rizios here is from BioRaces. He's the research director at BioRaces right now, and he can explain our biosensor and where we are in commercializing that and how it compares to other sensors that are currently on the market or under development.
That would be great. Thank you.
So as Dr. Burgess said, we at BioRaces are commercialized the technology from UConn, and I have it here is kind of too small to pick up. So the main difference from our sensor from the sensors on the market is that what's on the market is not a full device that is implanted. That's the main difference, that there are wires sticking out, and this causes problems, inflammation, and it's too big and it doesn't last for too long. For 5 to 6 days it can last. Our sensor, however, is fully implantable. It's just a small chip and is a full computer in it, and it has a coating, as Dr. Burgess explained, that prevents inflammation, and it can last for up to 3 months. So we're trying to commercialize it right now. We are going into human trials within the next couple of years.
So one thing that's unique about our sensor is that we have a coating on it that prevents a foreign body reaction. And that's why the other sensors that are on the market cannot work for more than about 6 days.
Okay.
First of all, they're much larger than our sensor, so they have to be implanted through surgery. Ours goes in via needle. And when they have to go in via surgery, then that causes much more trauma, much more inflammatory reaction. But also they don't have any coating that can prevent the inflammation like ours does. And so those sensors do not work for any length of time more than about 7 days. Whereas ours, right now we have a sensor that we've shown functionality up to 3 months, and we're developing a coating now that can last, that we've shown in animal studies, can last for 6 months.
And how will your sensor relay the information it's gathering? How does that part of it work? What will it interface with ultimately?
Okay, I can turn that question over to Professor Papadimitriakopoulos.
From chemistry.
Yes, our sensor is light powered and light communicated. We have here Professor Jane, who designed the whole scheme of powering and communicating. So the idea behind that thing is that the sensor goes completely underneath the skin, and then there is a proximity communicator, which is a very small device. We will bring it here very closely. And this device sits on top, and there is a light, and there is a wireless, and you can actually see the light, and it sits on top and powers the sensor and communicates with the sensor, and communicates with your cell phone, your portable electronics, and so forth. The idea behind this is that we relay variations of the internal chemistry of the body to outside without having to pierce or continuously piercing the skin. And now, with the combination of Qigong capability with the electrocardio monitoring, and also some oxygen sensors, sweat sensors, and so forth, we can get a much more holistic approach of the entire physiology from inside as well as outside. Outside is with the Qigong sensors, from inside is our sensor.
And we can also understand under different conditions like resting state and exercise state. I'd also like to point out that this is like a prototype, and so the actual final device would be much smaller if you fit it into just a normal watch type device.
Similar to the Fitbit monitors that are on the market
Exactly.
now. So everything we're seeing today is still obviously prototype and development.
I think the one main difference in our device is other people use RFID type technology. So they power it by using RF, like RF tags you see in,
Radio frequency.
radio frequency ID.
tags.
We do not use radio frequency ID, and radio frequency ID is prone to other interference, and they are much larger than ours.
So Dr. No, could you just explain to us this instrumentation and exactly what you are measuring?
Yes. So we developed the new electrode. That is the mixture of oil-based polymer, so with the carbon black powder. So basically, it works underneath the water, and as well as the air.
So basically, it can function when a patient was doing swimming activity as well as running
yes,
activity?
exactly. Yeah. So we already checked the measure. So when swimming, the ECC, we got a ECC electrocardiogram, the signal.
Okay, so it's measuring the patient's heart function.
Yes, exactly. Yes.
Okay, thank you.
Thank you very much. That's perfect.
But what's the main advantage of bringing in behavioral scientists like Dr. Gorin and others at CHIP now at this stage in the game early?
Well, as I mentioned, we have been working on our sensor for about 18 years, and I
But
think
early
Dr.
is
Chan
relative,
has been
I guess.
working for many years as well. And this is the first time actually even our group is getting together with Dr. Chan's group, so that is quite
That is
exciting.
also new.
But in order to get patients to really use and optimally use these types of devices, we need to have intervention packages developed that we do not have the capability of doing, and that is where the scientists at CHIP, such as Dr. Gorin, can really help us.
This is incredibly exciting from the behavioral scientist point of view, because one of the things we need most for patients is information. We want people to self-monitor how they're doing, and the device is going to allow people to have incredible amounts of information. Information can be motivating, but it can also be overwhelming. And so that's where we're going to work with consumers and the rest of the team to find out how do we best communicate this information to consumers, how do we use it to best motivate, can we draw on the evidence base from the behavior change literature and behavior change science to bring state-of-the-art behavior change principles to the intervention that is going to go along with the devices. What we don't want is a fantastic device that people aren't willing to use because it upsets them. They don't know what to do with the information, and so we need to spend time kind of developing that and hearing from consumers about what would be most useful. So we'll be doing some focus groups and relaying that information back to the team to develop interventions.
And to get them to take that information and make behavioral change, lifestyle changes. So in order to get that motivation for the patient to do that, we really do need the help of the CHIP scientists.
And in addition to focus groups with consumers, you're also going to be doing some interviews with doctors or other medical professionals. Can you tell a little bit about why you're doing that
Yeah.
and how that piece will ultimately be used?
So the potential here is fantastic. So not only can you communicate with the consumer, but that information can get relayed to the medical team in a real-time fashion. So hearing from the medical community about how they would like that information, how often do they want updates, in what forms, how would they then communicate back to their patient to make changes that are needed in medication or diet or exercise recommendations. And so when we're coming in, we're sort of doing a inventory of the landscape about what the different partners really need in this. So it's consumers and the medical team, and how to facilitate communication so that real change does happen as a result of the device.
So the initial focus of our center is on diabetes and obesity, so metabolic related diseases. But eventually we would like to move into other areas as well, other areas that we can measure chemically in the body, other disease states, things such as addiction and
I know. And various other diseases, for example, that we develop specific biomarkers that we look and target to see the progression of this disease.
But diabetes is a wonderful place to start because of the burden to both the individual but also our healthcare system. And it takes a person who's newly diagnosed with diabetes about 2 hours a day to manage their diabetes. And so with the information they receive from this device, they're going to know if their efforts are working. They might be much more motivated to keep those behavior change efforts going long term, which is really what we need.
It'll be much easier for them to adhere to
Exactly.
the treatment that their doctors
Right.
provided.
we also hope to generate information where we can see that a patient who has obesity is moving towards being type 2 diabetic, and maybe hopefully make an intervention change for those patients so that they do not become diabetic.
Right, get the information early and be able
Right.
to see
Right.
beforehand. It makes sense. I also was just going to ask Dr. Gorn a little bit about CHIP's strength in obesity. I know we talked about why it makes sense to partner your efforts with CHIP because of the behavioral scientists, but obesity is an area where CHIP already has quite a bit of strength that you're tapping into, correct?
Correct. So this is, again, another way that this is a perfect partnership. Right now at CHIP, we have a very strong obesity research interest group with over 150 affiliates who do active research in the obesity area. And we have a very nice core of faculty who are interventionists and able to motivate people to make behavior change over the long term, which is what we need for something like diabetes or just obesity management in general. So when we were approached about this particular device, we were extremely excited about the potential. And we recently brought the Rudd Center for Food Policy and Obesity to UConn, which is an internationally known center and has tremendous resources and expertise in thinking about how best to help people manage their obesity, the stigma that often goes along with obesity and other conditions, and a real sensitivity to how we might market messages that will appeal to consumers.
We actually get a lot of emails and calls from patients asking, when is your device going to be ready? Can we be part of a trial? We want to try it. So there is a real sense of urgency for us to finish this and make it something useful for the diabetic community and for obesity.